Hi, welcome back. Actually, I wish I have heard Isabel's presentation maybe a week ago. Maybe my story will be built up a little bit differently. Anyway, let's go. A little bit about myself. The picture on the top, you can see it now. Basically, below the picture is me in winter, as far as my holiday allows, of course. And the picture at the bottom is me in summer. Actually, there was an application at visitfinland.com website. You could type your name in, and they returned your Finnish identity. So this is my Finnish identity. The rest, basically, you can see and read in the brochure. Okay, the content of my presentation, short summary where we are today in test automation, then where we are heading, what are the changes ongoing in ICT domain. Then test automation as a service, you will hear what is it, and I will show how it can exploit those changes. A little bit insight of test automation as a service and conclusions. So the starting point, where we are today. On the right-hand side of the picture, you can see there is an SUT, a system under test. This may be in a simulated environment, target environment. This is not really important at this point in time. Mostly especially in system test or network, or as we could hear yesterday, in application test phases, installation configuration of the SUT is also typically task of the test teams. Then on the left-hand side, you can see the test automation workspace, and I didn't call it environment intentionally, because basically it includes a complete test design, IDE, development environment. So this is basically much more than just test execution and evaluation. The typical activities that the testers has with their workspaces are installing the environment, implement the test cases, then validating the test cases, executing function test, also maintenance the workspace, and it is also, of course, used for test execution. As you could hear yesterday from my colleague, Zoltán Csapó, nowadays the whole system is controlled and run often using CI, continuous integration environment. So this is the PC icon on the top. Okay, my presentation will not cover the whole picture, the whole topic. It's mainly related, or basically it's only related to the installation and the test environment part of the whole picture. What a typical test automation solution consists of. We have an underlying hardware, software, operating system part. This is basically an IT domain. So this is provided or requested from the IT department, IT support. Then we have a test automation tool provider. It may be internal or external to the company. It's not really the point, not so important, but this is one of the players of the whole picture. And then the users of the test automation tools, in our case, are the testers. And the typical structure here is that we have a test automation framework and the concrete test cases above. And very often we are using quite some third-party tools, also internal, open source, any kind of third-party tools. So in the best case, in the best situation, installing, maintaining, keeping the test environment running and working requires 3 players, if not more. So it's really a task that is not so easy and evident. And I can refer back to Antal László's presentation from yesterday, who explained and have a complete presentation pointing that how important from the testing point of view is the stability of the environment in which we are working. Okay, there is a changing paradigm in the ICT domain going on today that telco networks, applications are moved into a cloud environment. What it will change for the testers, for the test tools? In some sense, it may make their task easier because with applications running on cloud, typically deployment, orchestration of those applications is also delivered with the application itself. So hopefully there will be less problem, less work with those sides. But still, the test environment, the testing side, may remain the same. So it's further on installed manually, maintained manually, the same environment or similar environment problem may exist as before. Okay, so it still will be a time-consuming manual work. So the question is, why not to move the testing side also into a cloud environment? We have a cloud environment anyway because the SUT is already running on it, so we have the infrastructure for that. Why not to use this also for the test automation workspace for test design, test execution, and so on? Of course, this is a logical step. But if we are continue to deploy, to install, configure, and so on, or test environment within a cloud manually, then basically we didn't gain so much. We gain some resources, we can use the same infrastructure as exists anyway because of the system under test. So the next step would be to also apply some automatic deployment and orchestration for the test environment, making it quick, easy, automatic. So I'm using to say we should automate or test automation. It could be done for each of the test tools. We are using lots of different solutions, lots of different test tools. It could be done for each of them separately. But why to do this? Another way to do is to use some central, some common solution for deploying or test environment or test workspace. And actually, that is what test automation as a service is doing. So actually, what is it like is like software as a service in cloud environment or infrastructure as a service in cloud environment. Okay, looking at it from the users or the tester's perspective, he just requests a creation of his test, his workspace from the system. The system will automatically create the virtual machine, install the operating system, give the needed access rights, then installing the tools, setting the environments. So basically what the tester in this case has to do is just express his wish, what I want, what environment I need. And then when it's ready, then of course he logs in and uses this for his test tasks. Let us open a box a little bit. This TIS box, what components does it have? On the top we can see this is our web-based UI. This is the interface that the user and basically tool managers will meet with. Then the underlying big box, this knowledge management framework, basically is the heart of the whole system. It contains a knowledge base that has information about the all available tools. For each tools, we need basically just quite essential information. How to install the tool and what are the dependencies. So for each tool, very simple information is kept in the knowledge base. Then, when the user requests to create a working environment that may contain test automation tool, any additional utilities, supplementary tools, anything, then a workflow generator algorithm will calculate the workflow, so what tools in which order to install to create the requested work environment. The data store, of course, contains data, and there is an identity module just to check authentication, authorization, check the different rights. The system itself has different access categories, just for test execution, for tool managers, and administrators for the whole system. The green box on the bottom of the picture, they are not in the scope of TIS, they are just the underlying infrastructure the system is working on top of. Okay, let us look what the user can see and how the user can use the system. Here, now I have to leave the stage a little bit. On the top, you can see a small textual box. Basically, this is the place, this is the only information that the tester or the user of the system need to give what actually he wants. This is the end goal. There's no other information required from him. I want to create my working environment containing that and that test automation solution, test automation tool, and other tools, and Wireshark or Midnight Commander, so different tools that he wants to use in his daily, everyday work. Then the system, based on the end target, from 0, will calculate the workflow depending on the dependency. So he starts from the end goal and will calculate what tasks to execute to create the work environment. Basically does the same as the people would do manually. The difference is that there is less error prone. And then when the user is happy with this workflow, requests creation of the workspace, it starts and the system shows, you can see the green boxes on the bottom, and shows the progress of building up a working environment, the workspace. Okay, when the workspace is ready, then the user logs in and can use it just like any machine or any manually created working environment. This was basically all that a usual tester, so a user of the system, had to do. But of course, this is not sufficient, not enough to make the system running, to make the system know what are the working environments. There are lots of organizations, lots of users, lots of different configurations has to do. So what else the user can do? The user can manage its workspaces. So on the left-hand side, you can see a little menu that shows the available different workspaces. The workspaces can be suspended. That means that the image stored on hard drives to save resources. There can be suspended, resumed, started, stopped, and so on. So the workspace environment itself can be managed by the user. Okay, but how the system will know that what are the components, the different workspaces, the different work environments are compiled from. So for this, except the user access rights, there are tool manager access rights who are able to add, change, delete the different tools. Here you can see the tool graph of the tools currently available in the system, currently entered. So these are in the database. Each of the circles identify a tool, and the arrows identify their dependencies. Of course, this is the graph that the workflow resolution, workflow generator will use to calculate the workflow to be executed when a new tool is requested. Okay, tool managers, it's early a little bit, tool managers can change and can add tools in which process they basically has to define the name, obviously, the dependencies, and the installation, way of installation script for the different tools. Okay, that is how the systems works. And finally, the conclusions. The conclusions are basically the advantages of the system. What are these? First of all, time. So saving time, making things efficient and easier. There are some measurements has been done with 2 different test automation frameworks used in Ericsson, in our company. In one of the test automation solutions, a typical manual installation time took from 4 to 7 hours, so quite a significant time. The TRS system could decrease this time to 12 to 22 minutes, depending on the complexity, of course, which test framework, how complex is the test framework that has to be installed, and so on. With another test automation tool, a typical installation time is actually the concrete figure was less than an hour, but I think that that was an estimation or a figure from an experienced user. So I put 1 hour for the installation. And this could be brought down to 6.5 minutes, so in the range 6-7 minutes. So it's quite significant saving of time if we think that how many times we need to execute, we need to install test environments and update test environments, or even in CI workflow, if we have that amount of short time to create a new environment, even for each weekly or nightly test, create new work environment. Okay, another huge advantage of the system is stability. We could hear a presentation on this. The environment here is done by a machine, not by a human. So actually, it eliminates the typical human errors or the typical errors made by humans, missing dependencies, wrong version of dependencies, and so on. So once the workflow is created and tried out, it will always work. And the test environment will be stable. Also efficiency. I haven't showed this specifically in the screenshots, but of course, the work environment created can be shared between or inside a test team or an organization, or even already existing tool components can be reused by other organizations. So it saves lots of time within the team and inside the whole company. And then it can create quite a lot of saving of hardware and software resources, as we do not need the test environment always be available and up there. It can be created on the fly. This is basically something that is essential in cloud environments. Between the components that you have seen on the other slides, there are defined APIs, except one of them all are very simple HTTP-based RESTful APIs. So they can be controlled from continuous integration environments, of course. And though the name is test automation as a service, actually it can be used for other environments, for development environments as well. Just originally it was not the target. Originally the target was to make the test automation environment creation and maintenance easier, so that's why the name. Thank you for your attention. Questions?
I wonder how long it took to implement this solution for your company, and what was the team size. So just judging from, I mean, you have a lot of benefits, you gain the benefit, but have you ever measured, the ROI? What was the investment, and at the end, what you gained? That was first question. The second one is related to this framework. Do I understand correctly that this is very much tailored for your needs? So it's not a standalone solution that can be used by anyone, or it's just how you did and how you managed to build for your own needs. Is it correct?
I will start answering the second question. The whole solution uses quite a lot of open source components, especially for cloud management and for those parts. So what actually is added, the type of the job, the type of the work were mainly integration of those components, And what is actually added is this knowledge management framework that calculates the workflow. What will be the further policy, or how to say, regarding this solution? So will it be available outside the company or not? I don't know yet. There is no that kind of decision made or discussion yet. I don't think that this is basically rocket science, so it can be replied by other companies. The size of the work, it was basically done in a prototype phase was last year, and it took for 3 people about half a year, maybe a little bit more, with the final polishing and documentation and so on. So maybe a 3/4 of a year. The ROI basically was calculated based on the figures I have shown. So what is the time that has been spent to develop the system, and what is the estimated time that we can spare based on those decreased time spent on installation, and it quite significant advantage, quite significant financial return could be shown.
Okay, so we are running out of time. Thank you, György, for presentation.